Hello, Mario. In this question, we're working through another trig heighting example. The question is very similar to question 1. We are not calculating delta H. Delta H has already been given to us, possibly read directly from the total station. So this question is really about the correct formula and putting the values into the correct places. So the formula that we are going to use is the RL of peg B equals the RL of peg A plus instrument height, HI, plus delta H, which we've been given, and minus the height of target. Now let's put the values, let's draw a bit of a diagram first. Now this one here, I think we can see is going to be a bit of a depression. So I'm going to put something like this here, and we're going to put this is peg A, and we've got an RL for peg A. RL 74.350. And we're going to set our total station up over A. A total station, and we're going to measure the height of the target station, of the total station, the height of instrument HI as 1.545. Okay, that's HI, which is from the top of the peg to the axis of the instrument. Then over here at B, where the RL is unknown, RL there at B, we have got a prism being held here by our survey assistant. Very nice and steady, vertical over the mark. Like that there. And the height of the prism, which we'll put over here just out of the way, prism height 1.800, and we call that HT, height of target there. Right, now we've got our line of sight through there like that, and we haven't got a horizontal distance at all. We don't know what the distance is from peg A to peg B, but what we do know is that we have got the delta H, the difference in height, and it's minus 1.721. That is the distance, the vertical distance, from the instrument to the prism, the delta H. like so. And we want to calculate the reduced where the reduced level of B. So the formula we're going to use is the RL of B equals RL of A, like that there, plus HI plus delta H minus HT. Alright, and filling in, put the values in the questions. RL of A, 74.350. Height of instrument, 1.545. Now we've got plus, and delta H is negative 1.721. And then we have got to take away minus 1.80. All right, and we get that the RL of B, when we work that out, RLB equals 72.374. And that is our final answer. Now, if we look at this in terms of like a rise and fall sort of scenario, we can see how it works. So we start at A and we rise 1.545. That's the height of the instrument. Then that gives us a level, just there. Then we fall 1.721, delta H. And then we fall 1.80, the height of the target. And that gives us the RL of B. So with the diagram, I think it helps us to understand it. All right, now, that's pretty much it, really. The important thing here is that delta H was already given as a negative value. This means the target is lower than the telescope axis of the total station. So we didn't need to calculate delta H because it was given to us by the machine. In the previous question, we calculated it using the zenith angle and the horizontal distance. Oh, the slope distance, yes. Here we've got no distances involved. And so we do that to give us the final answer, which is 72.374. The key point is to use delta H exactly as it was given. If delta H is positive, it's added it as a positive. If delta H is negative, it's added as a negative, I think. Added as a negative. In this question, delta H is negative, so the final RL of B is lower than peg A. In this case, that sometimes not always the case, with very small differences. If this helped, please like and subscribe, because it helps the algorithm know that this type of surveying content is useful. If there is a part of trig heighting that still feels confusing for you, leave a comment. Let me know what you would like explained. And maybe that will be my next video. All good. Cheers. Bloody marvelous.